Hello guys, this is Anpichan. Welcome to my mathematics class. Let's see the today's topic. Today's topic is important questions on permutations part 2. Because already I have made one video based on the important questions of permutations. This is a second video online. That's why I've written here part 2. Okay, uh, let's not to waste the time. Let's move directly into the question number first. What is the question number first? In how many ways uh, can four boys and three girls be seated in a row containing seven seats? We have seven seats and seven persons. If they sit, if they may sit anywhere, there is no restriction. Anyone can sit anywhere. Then we can say the question in this way: seven seats are there, seven persons are there. Seven persons can be arranged in seven seats in seven factorial ways. All right, because we are taking all objects at the same time, right? So very easy question, very easy part of this question, only just 7 factorial ways, right? Now second part, if the boys and girls must alternate, right? Must alternate means like this, well, let me show in the diagram. Here boy, because four boys are there, so let's start from the boy, and we need here girl, and then we need here boy, then we need here girl, okay, then we need here boy, one two, okay, three, and then we need here girl, and then we need again boy. Look at here, how many boys? One, two, three, four. So okay, one, two, three, four. Okay, boys are come. So total boys are four. So complete it. And girls, okay, one, two, and three. Three girls are there, right? Girls, girls, girls. Okay. All right. There are three girls and four boys. According to the second part of this question, we must have this type of arrangements. All right. If the boys and girls must alternate, then these type of arrangement, okay, we should have, like firstly boys, girl, boy, girl, boy, girl, boy. And in this case, okay, boys and girls cannot interchange their seat. Boys and boys can interchange their seat, girls and girls can interchange their seats. So in how many ways we can find out the arrangement? So simple, as I told you, the boys can interchange their seats and girls can their interchange seats, but boys and girls can't interchange their seats because of this condition. So alright, so four boys, okay, in how many ways, okay, we can arrange four boys, you can write down like this way, four boys can be arranged in four factorial ways, and three girls can be arranged in three factorial ways, right? So total number of ways, what will be your total number of ways? Total number of ways in which the boys and girls must alternate is equal to 4 factorial times 3 factorial. This will be your final answers of this part. Okay, you can find out very easily. Okay, this is the calculation part. So I'm pretty sure you will not have any problem. Okay. Let's move into the last part of the first question. Very interesting question, very important question. All right. I'm going to your express. So next, see question number your third part of this question. Question is actually first, and I'm going to explain the third part. If all three girls are together, right? So all three girls, right? All three girls together. We want to be all three girls together. So as I told you in many videos earlier, if together, then how to find out all three girls together? Then we have to consider, just consider single girl, okay, right? Just consider, okay, single girl. Okay, we will consider three girls, okay, single girl, right? All three girls, uh, if all three girls are together, then we have to consider all three girls as single girl, as single member. All right. Okay, so how many boys are there? Four boys, right? Now number of persons, how many persons will be there, okay? Altogether how many members will be there, okay? And four boys plus one girl we will consider single. So five members, okay, five, okay, persons are there, okay, or you will write down the persons. So how many persons are there? Five persons. All right. Now we have to arrange, okay, 5 persons. 5 persons we can arrange in 5 factorial ways, right? In how many ways we can arrange, okay, 5 persons? We can arrange in 5 members. We can arrange in 5 factorial ways, okay? So 5 out, 4 boys are there, 3 girls we have supposed as one girl, right? As a single member. As a single member, right? 5 factorial ways. So 5, okay, persons can be arranged in 5 factorial ways, no problem. And but one more thing, okay, 3 girls, right? Although they are, okay, sitting together, they can interchange their seats, okay. 3 girls can interchange in 3 factorial ways. In how many ways they can interchange their, okay, 3 factorial ways, okay. 3 girls can interchange their seats in 3 factorial ways. So what will be your total number of ways? So okay, now I'm going to remove the first question. So okay, so total number of ways we will have 5 factorial times 3 factorial, right? So you can find out, okay, that will be your answers, right? Any problem? So if we have to find out the 3 girls are together, then we have to do like this way, right? 3 girls we have to suppose single and 4 boys are there. Now we will consider, okay, if we consider 3 girls, okay, as single member, then okay, we will have total number of members. How many? 5. 4 boys and 1 girl. And 5 boys, 5 members, sorry, boys not, okay, 5 members, let's say, okay, 5 persons, okay, can be arranged in 5 factorial ways. And 3 girls can interchange their seats. So 3 girls, can interchange their seats in 3 factorial ways. And total number of required ways is equal to 5 factorial times 3 factorial, right? This will give you the answer of the last part of the first question. Clear? I don't think now you have a problem, right? If you have a problem, you have a very easy access. You can write down in comment box. Okay, let's move into the question number 2. Second, okay. Question number second. I'm going to write down the solution here. Oh, very simple. In how many ways can 8 people be seated in a row? Now, in a row, so right, in a straight line, you can say 8 seats, so that two particular persons, okay, these two particular persons are always together. Same type of question. How many members are there? Okay, we have 8. 8 members are there. 8 people are there. Okay, 8 members or 8 people are there, and two persons. These two persons, right? Okay, uh, want to sit together, right? Always, okay, always. So these two persons, okay, we will suppose, okay, suppose single person, right? If we suppose, okay, two persons, single person, and then total number of, then we will have, okay, total number of members, okay, total number of person, total number of people. How many total number of people will be there? Okay, 8, okay, 8 minus 1, okay, now 7, okay, we will have, right? Because of the 2 we have supposed 1, that's why, okay, we will have 7 people, right? We will have 7 people. Now 7 people in a straight line, 7 people in a straight line can be arranged in 7 factorial ways, can be arranged in 7 factorial ways. Okay. In how many ways can be arranged? 7 people can be arranged in 7 factorial ways, right? 7 factorial ways. And but one more thing, two particular person can interchange their seats, okay? Two particular person can interchange their seats in how many ways? In 2 factorial ways, all right, because they can interchange their seats, right? And so we can find out the number of arrangements, the way they interchange their seats, right? That's your 2 factorial ways. Then what will be your total number of ways? Okay, in how many ways? Now we can find out, okay, in how many ways can 8 people? Now you can write, finally 8 people can sit in a row of 8 seats, so that two particular person are always together in how many ways? Okay, in 7 factorial times 2 factorial. So this will be your final answer, right? 7 factorial times 2 factorial. Okay, let me explain again once again. Total number of people. How many total number of people are there? Okay, 8 people. But two people want to sit together always. All right. Then we need to consider two people as a one, as one people, as one person. Then we will have total number of, okay, if we consider two people one, then we will have members, number of members, okay, seven. Then seven members in a straight line can be arranged in 7 factorial ways, right? Okay, 7 factorial ways. And but two members can interchange their seats also, right? And two members can interchange their seats in 2 factorial ways. Then total number of ways, what will be here? 7 factorial times 2 factorial, right? You know how many ways? So 7 factorial times 2 factorial ways, right? 8 people can be seated in a row of 8 seats, so that two particular person are always together, right? So this is the way to find out the solution of this question. All right, that will be the required number of ways, right, in which this statement is satisfied. Okay, now any problem? No, clear. Next, okay, three number also very important. Now, okay, let me erase all these things. Question number 3 here I'm writing. In how many ways can 4 art students and 4 science students be arranged in a circular table if they may sit anywhere? So very okay, good question. So how many? Okay, 4 art students plus 4 science students. So total how many we will have? 8 students, right? And in first condition, right, if they may sit anywhere, there is no any restriction, they may sit anywhere, right? So we can say 8 people here, 8 students can sit anywhere, right, in a okay, circular, or yeah, in a circular table. So we can use, okay, circular theorem, okay, circular theorem of circular arrangement, circular permutations. Okay, so what's that? Okay, according to the circular permutation, number of arrangements will be n minus 1 factorial. So let's use, okay, then 8 people for first, okay, a students here, students, okay, a students in a round table, right, round table. In a round table, can be arranged in how many ways? 8 minus 1 factorial means 7 factorial ways. This will be the answer of the first part, right? Okay, here I'm not writing properly. I'm just going to explain the questions here, right? You will try yourself to write down, okay? I'm going to tell, okay, I'm telling also, you can copy that, okay, right? So what to write down here, okay? Therefore, a students in a, okay, a students, if they sit, okay, if they sit anywhere in a circular table, can be arranged in 8 minus 1 factorial is equal to 7 factorial ways. Why we have used here 8 minus 1? We have used, okay, this formula, circular permutation, okay. This is the, okay, theorem of circular permutation. What is the theorem of circular permutation? Okay, total number of arrangements in a circle having an objects, a total number of arrangements of an objects in a circle is given by n minus 1 factorial. Exactly that one theorem I have used. All right, so now I think clear, right? Now second, okay, second we have a condition, they sit alternately. Okay, here is problem we have, okay, if they sit alternately, okay. So firstly, whom you are going to arrange, okay? If you are going to arrange, okay, as students, then you need to use, okay, here circular permutation. Let's suppose, okay, here art students, right, art students, and how many art students? 1 2 3 4, okay, right? You are going to arrange, okay, firstly for art students in a circular table. Then you need to use, okay, 3 factorial, right? 4 minus 1 factorial is equal to 3 factorial ways, right? And so 4 you can write on the, at first, okay, this language you will use, okay, at first, okay, 4 art students can be arranged in a circular table in 4 minus 1 factorial, 3 factorial ways. Firstly, you need to use the circular theorem to arrange, okay, 4 art students in a circular table. All right, and so later Yeah, or you can say the alternately, right? Okay, for science students alternately can be arranged in. So very interesting, listen to me. Okay, they will say now we have, okay, exactly four seats, okay, right? Exactly one, two, three, four. We have exactly, okay, space. Four spaces are there, right? We have not to fix anybody, okay, there as we do in the first case, okay. There are four students, okay, right? For science students, let's say four places are there. Four science students, okay. So we can use, okay, here. So, okay, alternately, later, the science students alternately can be arranged in four factorial ways, right? Why we arrange? Because we have four places here, one place, second place, third place, four, okay, fourth place. Four places, four members. Because, okay, firstly you need to arrange, okay, our students, you need to fix, okay, one student. That's why we use, okay, n minus 1 factorial. But, okay, later, okay, you will have a particular space, okay, space, okay, four spaces, four, okay, persons. So four science students can be arranged in four factorial ways, right? So for first, okay, four choices. For second, okay, three choices. For, okay, third, okay, two choices. And for last, okay, only one seat, okay, one choice. So four times, three times, two times, one time means, okay, one. This means, okay, four factorial. So four science students alternately can be arranged in four factorial ways, right? So now total number of arrangements, what will be the for this, okay, total number of arrangements, okay, 3 factorial times 4 factorial, right? So is equal, you can find out 3 times 2 times 1 times, okay, 4 times 3 times 2 times 1, and you can find out the calculation, right? You can find out this way the answer of this question. Clear, everybody? We any problem now? I don't so think you have any problem, right? Now you understood, okay. If you, okay, arrange, okay, once again let me explain. If you arrange, okay, for a student at first in a circular table, then you need to use, okay, circular theorem. Okay, by using this theorem we can arrange for our students in a circle table in 4 minus 1 factorial, I mean 3 factorial ways, right? And thereafter, okay, 4 seats automatically will be created, okay, alternately, right? Alternately, so for our science students can be arranged in 4 factorial ways. Then we don't need to apply circular theorem, right? So total number of ways in which they sit alternately is equal to 3 factorial times 4 factorial is equal to 3 times 2 times, okay. Like this way you can find out the calculation, right? This is not a big issue, okay. So clear? Then if, okay, this clear, let's move into the next question. So, in how many ways 8 people be seated in a round table if 2 people insist in sitting next to each? This is also a very easy question. Now, I think you can do, but in the, okay, first question we have done, okay, before that, okay, question, but that was, okay, in a straight line. Here is a round table. So simply, okay, there are 8 people. How many people are 8 people? But here also 2 people insist, okay, sitting next to each other means, okay, together they are going to sit. So, okay, 2 people we have to consider, okay, one, okay, we have to consider one, okay, one, and then total number of people will be your 8 minus 1, we will have a 7 people, right? And 7 people can be arranged in a circular table or in a round table in how many ways, okay? In 7 minus 1 factorial ways, okay. In how many, okay? 7 minus 1, okay. That is, okay, you can say 6 factorial ways. So simple, right? But, okay, let me explain again. Let me again repeat, okay. There are 8 people, right? They want to sit, okay, round table, but out of them, okay, 2 out of them insist to sit together, all right? And then 2 people we have to suppose, okay, we have to consider as single people, a single person, okay, we have to suppose. And if we suppose, okay, 2 people as single, then we will have, okay, number of persons 7, okay, 8 minus 1, 7 people will be there. So 7 persons can be arranged in a round table, 7 minus 1, okay, factorial. So 6 factorial ways we can arrange, right? So I don't so think you have a problem here. And then, okay, so again, okay, 2 people can, okay, no, interchange their seats in, okay, 2 people can interchange seats, okay, in 2 factorial ways, right? 2 people can interchange their seats, okay, in 2 factorial ways, as I told you already, okay. This type of statement is going to repeat it, right? Going to be repeated. So what will be your final answers? Okay, total number of, okay, 7 people, okay, 8 people, 7 people can be arranged in a round table 6 factorial, and 2 people, okay, can interchange their seats into factorial ways, and total number of ways, what will be your 6 factorial times 2 factorial ways, right? So this will be your final answers, right? You just need to multiply, okay. Product of these two is the answers of this question. Okay, so simple question, very easy question, but very important for 2 marks question. All right. Okay. So we got, okay, a big space to write down the remaining question. Alright, the next question, 5 number question, very easy but important and little bit, okay, confusing question, right? How many numbers of 6 digits can be formed, okay, from here, right? With these digits, okay, let's see, okay, we have a 2, 3, 2, 0, 3, 3, 1, 2, 3, 4, 5, 6, okay, right? So firstly, okay, 6 digit number you can find out, right? Number of arrangements, right? Yeah, 6 digit numbers in which 0 may come at first, okay, right? So you may write down, okay, because there is a 0. If we use a formula, 0 may come at first also, right? So you may write down like this way. Listen to me very carefully. Number of arrangements, okay, of digits to form a 6 digit number, or a number of 6 digit number in which, right, first digit from the left may be 0 or may not be 0, is equal to, okay, that, okay, right, is equal to, how many digits are there? 1 2 3 4 5 6. There's 6 digits, okay, 6 factorial. Here we need to use the theorem of, okay, permutations of all objects not different, right? Of all objects not different. So what's that formula? N factorial over p factorial times q factorial times r factorial, this formula. So exactly this formula we have to use, right? Because here, so 2 like objects, okay, here 1 2, and then over 1 2 3. So here 2 factorial, because 2 is coming 2 times, and 3, digit 3 is coming 3 times. So that's why, okay, 1 2 factorial times here 3 factorial, this one formula we will use. Here 6 times, okay, 6 times, 5 times, 4 times, 3 times, 2 times 1 over 2 times 1 times 3 times 2 times 1. Okay, cancel, and 2 here, 2, 5 is 10 here, 60. Listen to me, 60. Listen to me very carefully. 60 numbers, right? 6 digit numbers we will get, okay. 6 digit numbers we will get, in which, okay, 0 may come at first, okay, 0, or 0 may not come at first from the left side, right? From the, so you might have a number like this, right? 0 2 3, right? 0 2 3, right? And like this way, okay, 2 1 2 3 4 5 6, like this way you may get, right? Okay, 0 2 1 2 3 4 5 6, okay, 6 digits completed, okay. But this is the 6 digit, but okay, 0 is at first, okay. Right, okay, in number system, okay, if you write down the 0 at first, okay, that is not, okay, and significant numbers, okay, that, and we read, okay, this one ultimately, okay, we read this one is 5 digit number 23233, right? We ignore, okay, 0 if it comes at first. But okay, here due to using this formula, we may get, okay, this type of number also, right? This, okay, 0, okay, in which 0 may come at first, right? Okay, now we have to find out exactly 6 digit number. Exactly 6 digit number means, okay, we should not be start from the 0 from left side, right? Okay, so let's see, let's find out now 0, the arrangements in which 0 comes at first from left side. Let's find out, right? Okay, 0 comes at first from left side, okay. So how many? 1 2 3 4 5 6. Look at here, everybody. Let's fix the 0 here. Fix 0 at first, okay. First means, okay, the first from left side, okay. First from right side, okay. First, okay, from left side, okay. So let's fix, okay, 0 at first, and then okay remaining, okay how many zero how many numbers will be there? One, okay, 1 2 3 4 5, so five numbers, 1 2 3 4 5, right? So remaining okay places can filled up in 5 factorial, okay, over 2 factorial times 3 factorial ways, right? So here is equal to 5 times 3, 4 times 3 times 2 times 1 upon 2 times 1 times 3 times 2 times 1. Okay, 3 to the 6, 3 to the 6 cancel. Okay, 5, 2. So how many? 10, right? So 10. So we will get, okay, 6 digit, right? 10, listen to me very carefully. 10 6 digit number in which 0 comes at first from left side, right? So how many numbers are there, okay, in which we get, okay, 0 at first, okay, 10. So here total we got, okay, 60, in which 0 may come at first, may not come at first. So let's remove, okay, the numbers, right, in which we get 0 at first, okay. So 60 minus 10, right? So 50, okay. This is exactly 6 digit number, exactly 6, right? Significant 6 digit number, 50 numbers you will get, right? 50 numbers you will get, okay, right? In 50, okay. So how many numbers of 6 digits can be found with this, with the digits this? Ultimately we can find out 50, right, 6 digit number from the given digits in which, okay, 0 does not come at first, right? If 0 comes, okay, at first, okay, then that number reduces to 5 digit number, right? So 50, okay, how many 6 digit number you will get, okay, from the given digits? 50. All right, now I think you understood it fully. If you have problem, you have option. Okay, let's move into the next question. Here, these all are very important questions, 2 marks question. How many even numbers of 3 digit? Okay, very interesting. Okay, even numbers of 3 digit can be formed when repetition of digits is allowed. If we'll see there is a no digit, then how to make the 3 digit numbers? Listen to me. If it is the matter of the digits, then so how many digits are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? These are the digits, right? How many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 digits are there, right? How many even numbers of 3 digits can be formed when repetition of digits allowed? All right. So 3 digit number, even 3 digit number, okay, even number, okay, right? Even numbers of 3 digits, we want to buy even number. So how we know, okay, even number, how can we form, okay, 3 digit even number? Listen to me everybody. In order to make the 3 digit even number, then we have okay, we have to keep even numbers, right? Even numbers at unit place, right? Even numbers at unit place. So let's see, okay, repetition is allowed here. 3 digit number is 1, 2. Okay, this is the unit place, tens place, and 100 place. Very simple, right? In unit place, okay, we how many digits we can take? You can use, okay, in unit place, okay. For this we have either you can use, okay, 0, you can use, okay, 2, or you can use 4, or you can use 6, or you can use 8, okay. Any one of these numbers you can use here, right? You can use either 0 or 2 or 4 or 6 or 8 in order to make even number, right? 3 digit even number. Okay, so 1, 2, 3, 4, 5. So how many there are? 5. In how many ways, okay? We can fill up, okay, unit place in 5 ways. Alright, unit place in 5 ways. And now you can, okay, here tens place, you know the repetition is allowed, okay. There are 10 digits you can use, okay, anyone can use, repetition is allowed. That's why this can be filled in 10 ways. And 100 place can be filled up in, you know, right? Okay, in 100 place we can take, okay, 0. If we take, if, okay, if by chance, okay, 0 comes here, then this number will not be 3 digit number, then it will be reduced to 2 digit number, right? So okay, so in how many ways we can fill up 100 place? Okay, so we can't take, okay, 0 here, we can't take here 0 to make three-digit number. So we can take any one because repetition is allowed. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in how many ways we can fill up? Because any one of these numbers we can take. Alright, so in 9 ways we can fill up, right? This. Okay, any problem here? So what will be your total answers, right? So three-digit number, how many three-digit number we can make? Okay, three-digit number 5 times 10 times 9. Okay, 9 5 is 45, so 450. This is your answer, right? So I think you understood. Okay, now you can write down. Okay, so you will not have any problem in writing, right? So 450. Even numbers of three-digit can be found from the given from the digits if repetition of digits is allowed, right? Okay, so very simple, right? I think you are enjoying, you are learning, and you are getting at least something, right? Which is very important for you. And let's move into the last question today's, right? I'm also happy because I'm finally at last question, right? I'm going to explain. In how many ways can four letters be posted in six letter boxes, right? In how many ways four letters be posted in six letter box? Listen to me, okay? So also I think okay you have seen okay letter boxes, okay, because this is the age of information technology and the age of internet, so it's very difficult to see letter boxes. Okay, once upon a time, okay, in our country we had letter boxes, okay. Nowadays I don't also find letter boxes. Okay, so four letters, okay, be posted in six letter boxes. Listen to me, if you have to post, okay, there are six letter boxes are there, right? Let's suppose okay letter boxes 1 2 and 3 4, and next one is a 5, and next one is 6, okay, right? So we have a six letter boxes. These are the letter boxes, right? So letter boxes, now we have to, okay, four letters, okay, you know, right? Okay, one letter you can post anywhere, okay, there is no restriction, okay, right? So you may use, okay, here one letter, okay, here, or you can post here, or you can post here. Either you can use this, or you can this, you can this, okay. So for one letter, okay, for one letter, okay, in how many ways you can post? Okay, six ways, okay. First letter can be posted in six ways, okay, right? And similarly, okay, second, third, fourth. Restriction, okay. If you have posted, okay, first one here, then there is no any, okay, restriction. You can't post the second letter here. You can post, okay, here. Repetition is allowed here, right? This is a question based on repetition, right? So you can use also, right? For first, okay, six ways. For second letter also, you have six ways, okay. You can post, okay, in six ways. 1 2 3 4 5 6. And third letter also you can post in six ways, and similarly the final letter also can be posted in six ways. So total, okay, in how many ways you can? 36, I think 12 9 6 ways, okay, right? Okay, so in how many ways you can you can post the four letters in six letter boxes, okay. In 12 9 6 ways we can post. Now you, I think you understood, right? So okay, now I have, okay, explained each and every important questions of permutation, okay. So go through my both videos, my almost, okay, all videos based on the permutations and combinations. Definitely you will be benefited. All right, so thank you very much for watching. Bye bye.